I am the engineering manager on our delivery engineering team. Previously, I've worked as an SRE and a software engineer at DigitalOcean as well. And what the delivery engineering team does for DigitalOcean is we're basically building primitives for all of our product engineering teams so that they can deliver their applications more quickly and they don't have to spend time doing the same stuff over and over and over. Today, what we have is everyone basically, every single one of the teams, when they need to ship code, they need to write playbooks, or rather, in the chef terms, recipes, cookbooks, set up their services and all that stuff. And so what my team is supposed to do, we're a 2 weeks old team, so we have still some ways to go. We're basically supposed to abstract all of that away and provide a platform internally for all of our engineering teams to ship their code on. And so one of the things that we've been looking at a lot in the past few months is Docker. We have a lot of services that don't really fit the Docker paradigm, but we also have a lot of services that do. And we're increasingly moving towards that, where we actually have stuff we can ship with Docker. And so while we've been looking at Docker and talking to people, one of the things I noticed in conversations with everyone is people don't really use Docker in production that much. And I think largely Frank covered some of the issues with it. Is the security has been questionable up to this point. They actually just released some in 1.8.0, which just shipped a couple weeks ago. I think within the last month, they fixed a lot of the issues that people have had with Docker previously around security. So it's getting better, but there's still a lot of rough edges. And while Docker itself is just one technology, there's also surrounding considerations from the operations standpoint. So Docker is just how you encapsulate and ship your application, and that's great, but it doesn't solve a lot of the operational stuff around it. So I'm going to go into some of those, and Frank already covered some of that stuff, so it's going to be a little bit of repetition, but hopefully I can provide some additional insight as well. So with that, some of the topics that I wanted to hit on that have been very recently in my mind are the 5 that you see here. And in the end, I'll also have a couple of other topics that I can just quickly hit on. So deployment. Traditionally, I guess the state of the art for a lot of people is you have a SSH for loop or a configuration management tool. Sometimes they're the same thing. And that basically takes your code and puts it on a server and does upgrades in place. So when you ship a new version, you just pull down the latest version of let's say from your GitHub, and just you flip a bit on the server and off it goes. Now, that doesn't really work with Docker, because Docker, the whole idea is that you encapsulate your code into these containers and you ship those as your artifacts. So you can't really do that in a great zero downtime way out of the box. And so one of the things we've been looking at is like, how do we build a system that allows us to do zero downtime deployments, and how do we enable our developers not to worry about those fiddly bits, right? So essentially, you want to have some tooling that sits at a higher level of abstraction and orchestrates it for you. So what I've pulled out is a list of few services or few tools that are sort of the state of the art in this current space. So Docker Swarm is the thing that Docker itself is developing, and it ships with Docker. It's their solution to this problem. Now, I would argue it's not yet perhaps the best one, but it's good enough that you can get started with it out of the box. Now, Google has been working on a project called Kubernetes for a while, and it's a container-only orchestration tool, and it is, in my opinion, it's probably the most sophisticated out of the bunch, just because it has a lot of, Ken over there from Google is very happy about that. It has a very robust set of primitives. It actually tries to walk you through the whole life cycle of shipping your containers into production. Like, it really gives you a lot of stuff out of the box. And some of the things that it does beyond just like taking your container and putting it in a box, it has a primitive for secrets. So storing secrets is one of the hardest things once you get to a point where you don't want to put them in your source control. That's very difficult, in my opinion. So Kubernetes is nice enough that they actually provide a primitive for you to put your secrets in Kubernetes itself, and it'll basically just pull it down to your box when you put it into a definition file. Now, the other thing that's sort of emerging in this space, or has been emerging for a few years, is Mesos and a bunch of its frameworks that are used by companies like Airbnb, Twitter are the two big ones. Apple is now using it. Verizon just announced that they're going to be shipping Marathon in all their data centers. So that's like an area of active development. And having just gotten back from MesosCon last week, I can say that it is a very interesting space. So I would definitely encourage you to look into both Kubernetes and Mesos on top of Docker Swarm if that doesn't quite cover it for you. Because both of those projects are being developed and really provide like really great tooling that you can then provide to your developers. And so I should say that as a background, while I consider myself a developer, I'm definitely more on the operations-minded developer. So having been an SRE, my primary customer is the developers inside of our company. I'm not building stuff for the customer outside, at least not yet. And so I want to make sure that the user experience we provide for our internal developers is as comprehensive and as easy to use as possible, which is where I feel like Mesos and Kubernetes really have a sweet spot. So load balancing, this is another one. So state of the art, again, you have HA Proxy, Nginx. If you're not using your cloud provider's service, ELB or Google probably has one, I forget the name of it. And those are fine, but typically the way you configure them is you have a config management system, I hope, and that pulls down data from an external source that it has been indexed to after you've run your configuration management tool on those hosts. Or if you're using Ansible, you have an inventory file or something like that. Basically, so you have an external store somewhere, and that's where you get the data from. But again, with Docker, this gets a little trickier because one of the things that Docker enables you to do is ship things very quickly. And configuration management tools really don't help with that because they're typically designed to be run periodically, once an hour, once in a half an hour, once a day. And if you're shipping code every 5 minutes, or like Amazon does every 7 seconds, running these tools gets really expensive because they typically take a long time to run, anywhere from a few minutes to 15 minutes to half an hour even. So if you're changing code every 7 seconds, that doesn't really work for you. So with that, you need something that bridges the gap between very dynamic services and your load balancing. I'm assuming you're not changing your load balancer out, which you can still do. Like there's actually, so I've listed Vulkan-D, which is a etcd-backed load balancer. So your services register themselves to etcd, and then Vulkan-D just pulls that data down and immediately reloads its configuration, or the load balancing configuration it has. And that's great, but provided that you want to stick with your tried and true HA Proxy or Nginx configurations, you're kind of out of luck. And so in that case, you should look into having a service discovery first and foremost, but also looking at these Sidekiq processes, confd and console template, which allow you to basically pull data from a service discovery server or service, and regenerate the templates for your HA Proxy or Nginx based on that data. And that's really great because it gets you very dynamic configurations with very little work. Another one that I'll hit on is logging. So most of the application frameworks like to write their logs onto the disk. When you have read-only or, well, let's say you have read-only containers. One of the things Docker really embraces is immutability. So it allows you to do immutable deployments, immutable artifacts. So you know that the thing you have in development is the same thing you have in staging, that you have the same thing that you have in production, right? That's great. Problem is when you start writing logs, you want to have those logs available to you. And you typically, most application frameworks write them on disk. So that doesn't really do it for you. So a couple options that you have out of the box, are you can mount a volume that you then expose. So you can expose the underlying host where the Docker runs to your Docker container, and you can start writing your logs there. But that still requires you to run another process on the host to pull the logs from there, and that's kind of iffy. As I wrote up there, it also makes your containers less portable across different environments. You might have different operating systems, or you might run just different configurations. It means that you're always having to ship that same volume configuration around, which is not great. So instead, what you should try to do is actually have your applications write your logs to the standard out, standard error of the process that launches your application server on the container. This allows the Docker daemon to then go ahead and pick up those logs and expose them to whatever the underlying system is that pulls them. And so by default, Docker comes with a number of different drivers. There's a non-driver if you're just like, I don't need logs, which is probably not a good idea. The default one that Docker uses itself is called JSON file. And what that allows you to do is it basically writes the logs to the underlying Docker or the underlying host file system, which you can then go poke at and look at. But it also allows you to run a command called Docker logs, which I think Frank actually demonstrated. And then the one I would recommend is syslog. Is just, you can send them to any syslog service. There's a lot of hosted services out there, but you might also be running your own syslog service, or you might run like Elastic or Logstash, which can also index those. So there's a lot of options there. Now they've also added journald if you're a systemd guy or gal. Guelph and fluentd are also now available if you want them. But I personally, syslog is pretty good. So it just allows you to take logs as they're coming in or coming out of your application and ship them directly to whatever system you use to collect your system logs anyway. And this is an area where the Docker plugin system that has been recently announced is going to add more options. So I would expect that providers are going to have their own plugins. So if you use Papertrail, you could probably have a Papertrail plugin for Docker, and it'll just do the magic for you. You don't have to worry about any of the setup, which is nice. So my favorite topic is secrets, because traditionally people like to store these on like their source code, and they'll be like, oh, we use configuration management to put them on the system. Well, you still store them as source code because your configuration management still needs them mostly unencrypted. Now, some companies have actually gone ahead and developed pretty complicated systems to manage the source code in secret. So they encrypt it and then they decrypt it on the host, and it gets messy. So Docker has traditionally advocated for like, oh yeah, you just pass them in as environment variables, which is great, except somebody, let's say they compromise your box, they can go and look at those. And so now you're kind of out of luck. Or the other option is you just mount a volume that has a file that contains your secrets. And that works okay, but I think we can do better. So some of the options that I've seen emerge in this space recently are Vault. It's like a secret service store API, sorry. So you can call it, and given you have the right credentials, it'll give back secrets. And that's pretty nice. It is very flexible. It's under active development. They're adding different ways, different systems and different ways to use it. It can do stuff like PKI for you. So let's say you want a TLS certificate for every single one of your services, which I would highly recommend, by the way. Even if it's internal to your data center, it can do that for you. It can give you MySQL credentials dynamically. It has a thing called leasing, which means that you can revoke those credentials, or you can request that the consumer's clients renew those credentials once an hour, for example. So it's a really nice way to make sure that there aren't any credentials in the wild that are being utilized by somebody who shouldn't have access to that. And it has audit logs and things like that, which really make it a complete solution, in my opinion. Then there's a thing called KeyWiz. Square pretty recently open sourced that as well. The idea behind KeyWiz is it gives you a read-only volume, which is in memory. So you can mount that either inside of your Docker containers or in your host system if you have something running on the host system, and you could just read them off the disk. And that's pretty nice. It works. And then there's a commercial solution that a lot of companies have been starting to use called Conjur, which ties into all sorts of systems like, let's say, your configuration management systems, or it has APIs. So it's very similar to Vault, but it has a lot better integration out of the box today. I would expect that Vault will catch up pretty quickly to it because there's a lot of community interest in this space, mostly because it's a very hard problem. And also I mentioned, depending on your orchestration tool, if you're using Kubernetes, it actually has a primitive for managing secrets within it, so it actually takes care of that for you already, which is nice. I would definitely recommend checking that out. And then probably another really somewhat difficult topic, which we don't often need to do before, unless you run like a highly microservice infrastructure, is service discovery. So traditionally, again, we ship a service to a given box, we run it on a given port that we, predefined port. That's great. Now we can use the DNS record, maybe it's an SRV A record, refer to that service, and we're good to go. Now with Docker, you ship a service, it comes up, it's a random port. Okay, so how do you find it? So the way you go about doing that is you basically have a service that's external to your service. You have a service discovery service that's somewhere else. And when your container comes up, your container can either say, hey, I'm here, and register with that service discovery service, or you have a Sidekick container, which is, the concept of Sidekick is basically you have the main container, which is your application, and then you have a Sidekick that comes up and does something useful with your main container. So that can be something that just registers your service. And there's a few good examples of this. Jeff Lindsay, for example, has written a service called Registrator. I believe it's called Registrator anyway, and which does this for you, so you don't have to actually change your application at all. It just when your services come up, it just registers with a variety of different backends. So there's basically three options in this space that I would recommend looking at. So Consul is a product, again, from HashiCorp. It's a very nice product. We're looking at it internally and using it. It provides you a DNS interface to your records, so you don't actually have to change anything necessarily. It also provides a key value, an event system, and a few other things, and it constantly is getting more and more features. So it's really rapidly evolving, and it's very useful outside of just service discovery. The other one that's very popular nowadays is etcd. It's from the good folks at CoreOS. It has a little bit fewer features, but it is being used by a number of good projects, so it is quite battle tested at this point. Kubernetes, for example, is actually powered by etcd in the back behind the scenes. So these things in combination with some of the tooling, orchestration tooling, you don't actually have to use these because these primitives are built in. And I should say Zookeeper is sort of the classical one that everyone has used at some point and everyone likes to hate on. But it's actually pretty nice. It just requires you to basically build everything yourself, which is not as great of an experience, which is why Consul and etcd actually exist. So yeah, you have to, as I wrote, you have to register your application yourself or have a sidecar process that basically when your containers come up, it just takes those containers and registers them for you, which again, you can avoid by having good orchestration tooling, which again, I would highly, highly recommend. So with that, there's a few other topics that I didn't cover here, but I do want to mention. So Metrics is one that we've been internally adopting new tooling around this just because we have a lot of services that come and go, or I should say a lot of servers, but also services. And the traditional tooling doesn't really scale to support them that well. At some point, your Graphite box will fall over. And so we've started looking at and using a service called Prometheus from SoundCloud, and it's been working really well for us. Monitoring is another one that is sort of evolving. If you use Prometheus, you can actually use another feature of Prometheus to provide yourself monitoring, so you can look at this metrics that are coming out of your services that you're logging, and then use those to drive your monitoring with another piece of software called Alert Manager. And I'm sure there's plenty more that I'm not just thinking about right now. Another one, I guess, called Sensu, which is designed for more cloud-like environments where things come and go pretty quickly. So I would argue that the traditional monitoring tooling isn't very well suited for containers, just because it takes a long time. Something has to drive the change of configuration for them. And again, you could use things like confd or console template, but those are kind of, it can get a little messy. So I would definitely start looking at other options as well. And if you're running on a cloud provider like Amazon, they obviously have services that you can also tie to, but you need to write some glue to get that going. Networking. So it's great when you have a container, but then when you have a bunch of containers, it gets a little interesting to, like, how do they talk to each other? And that's where service discovery becomes very useful. But sort of a topic that has been making rounds a lot recently is, well, why don't we just give each container its own IP? Like, wouldn't that make it a lot easier than figuring out which board is where and whatnot? So Docker has been, or the Docker community has been doing a lot of work around this. Docker acquired a company called Socketplane, who is basically going to build the Docker's own version of networking, but there's also a few other options. So there's a company called Weave, who's doing really interesting things with networking, overlay networks, and another company, another product called Flannel from CoreOS, which is sort of the same, but a little different. And I'm not a networking person, I can't tell you exactly what the subtle differences are, but they're all worth looking out for, or looking at. And then my favorite topic is stateful services. So when people are like, yeah, I'm running my databases on Docker, I'm like, yeah. So what happens when your Docker container goes somewhere else and your data stays on the host? Like, that's a problem, right? Maybe. So Docker itself has exposed an API where you can plug in a storage backend, and there's a startup called ClusterHQ, who has a product called Flocker. And the idea is that basically they can replicate your data around with your containers, making it really nice to basically move stuff around. So again, I wouldn't necessarily recommend, in my opinion, Docker is not really great for stateful stuff, but it's really great for stuff that doesn't have state, or where the state lives somewhere else, like a database or memcached or some other key value store. So stateful things are worth really thinking about because they can get real tricky. And then I wanted to just put some parting notes or thoughts. So a lot of times we like to build things ourselves, and that's great, but there's a lot of stuff happening in this space. A lot of services are coming around, especially from the hosting providers. Google and Amazon are really trying to push the envelope so that they can take on as much of your operational responsibility as possible. And so I would really encourage people to look at what they're offering and whether that can solve some of your problems. And there's a lot of interesting examples out there right now where companies have had really good success with some of the container services, for example, ECS and GKE. So I would encourage looking at those. And if you do decide that you want to ship Docker, ship it incrementally. Do small stuff first. Like, don't ship anything that's business critical. I had a good chat with the folks from Shopify about their experience, and they're like, yeah, it didn't quite work the way we expected it. So, like, just start small. Start with something that is not the face of, like, that, not Google.com. Even though if you're Google, you already do that, so that's fine. But like, start with stuff that doesn't, if it goes down, if it breaks, because it will probably break initially, it's not going to impact your business. Like, that's my number one advice, is just make sure it's small, it can go away, it can be broken for a while, and then you fix it and you learn and you move on. And then the other thing is, this space is evolving very quickly. This space barely existed a few years ago. We've come really far since then. So really, if you're going to invest in this, be prepared to stay up to speed with everything that's going on. There's a lot of conferences, there's a lot of people doing interesting things, but the reality is that most people are not shipping stuff to production. There's a lot of hype, but it's going to get good, and there's real good reasons behind why there's a lot of hype. It's making people's lives easier, but because everything is evolving so quickly, you have to stay up to date on things and really pay attention. You can't just like let a year go by and be like, well, everything changed. Like, it just happens. And I've sort of like, I stopped paying attention for a month or two, and it, like, again, standards of ways of doing things just change all the time. As an example, today, Docker doesn't have a way to expose secrets to your underlying containers, but soon, or so I'm told, they are going to have a first-class primitive where you can say in your Docker file, I'll have these secrets and I want to expose them to my container. And I don't know exactly what the interface is going to look like, but they're going to basically pull it from an external source like Vault or Keywhiz. And again, this will take a lot of your operational pain away. So keep an eye on that for that. And that's it. That's all I had. Thanks.